Okay, we have maybe 3 little things to cover today. 2 of them are connected to the case for adding vectors together. The other day I told you that there are 2 ways in case for. You can either break things into their components and find the resultant, or you can use the sine law, cosine law. In grade 11, using the sine law, cosine law wasn't really an option because you didn't know it at that point. But now it's an option because you do. So usually what happens is people always want to use the sine law and cosine law. And I always say, well, you can't always do that. Why? Because sometimes, like in the first question you're going to do for homework tonight on page 463, sometimes you have a vector that's going down, south, and then a vector that turns this way, and then a vector that turns this way. And the resultant is here. You cannot use the sine law and cosine law here because this is not a triangle. So for this one, you would have to break these 2 down into their components. And in the question, you're given this angle and this one down into its components. And again, in the question, you're given the hypotenuse and the angle. It tells you 3.4 kilometers south, 26 degrees east. So you have enough info, so you find the components, and then it's almost a right angle triangle, right? This one goes up a little, so the legs would be here. And so this little piece, this isn't drawn perfect, but anyway, you can find by doing adding and subtracting in the y and adding in the x, you can get the legs and then you can get the hypotenuse, okay? So I just wanted to mention that so that it doesn't mess you up. But lots of times you can use the sine law and cosine law. So I'd like to do a sine law example with you, because breaking into components I think you're pretty good at now. But we haven't actually done any of these. So the example is going to say something like, an airplane wants to travel to an airport 600 kilometers north, 36.87 degrees west away. So this is what the airplane wants to do. So the airplane's down here somewhere, and it wants to go north 36.87 degrees west. So it wants to go over here, where this angle right here is 36.87 degrees. Okay? That's what it wants to do. But here's the problem. The wind is blowing 80 kilometers per hour west. If the wind is blowing 80 kilometers per hour west, and I aim for this spot in my, which is the airport, in my airplane, I'm not going to end up here. Where am I going to end up? I'm going to end up west of it, and I don't want to end up west of it, right? So I need to aim further back here. This is what I need to do. And then I let the wind carry me the rest of the way. So this is the wind. This is the 80 kilometers per hour west that the wind is traveling. Okay? So the question wants to know, what direction should I head? So what I'm actually going to do with respect to the air is this, so that my resultant will be this guy. Okay? And it says that my plane can travel 240 kilometers per hour. So that's this side. This is what my plane is doing, 240 kilometers per hour. This is what the wind is doing, and in the end, this is what someone on the ground sees me do. Okay, so the first part of the question wants to know, well, what direction should you head in? So to find that, remember the big angle from this outside line here, from the north axis, this whole thing is 36.87. But I'm going to need to find this guy. Okay? So I have a side, and I have this 36.87. How does that help me? Well, Well, you can think alternate interior angles, and if you do, then this is also 36.87, right? If there was a straight line coming down here, right? The said rule. And if this is 36.87, then this guy in here should be 53.13. And so now when I look, I have an angle and its opposite side, and a side, I could find this opposite angle. And that's what I need to do. And to do it, I can use the sine law. So I can do sine theta over its opposite, which is 80 kilometers per hour, is equal to the sine of 53.13 over 240 kilometers per hour. And now solve for sine theta, bring your 80 up. So sine theta equals 80 kilometers per hour, sine of 53.13 over 240 kilometers per hour. That's like 1 over 3, and the sine of 53.13 is 0.8, so 1/3 of 0.8. Take the inverse sine, and I think you get 15.466 degrees. So that's this theta, but that is not what I'm looking for, right? So they need to turn 15.466 degrees off of where they want to go, but that's not helpful. We need to give our directions with respect to east and north and west. So maybe the red. So I can get this angle from the north, right? Because the whole thing is 36.87 degrees. So I could subtract my 15.466 degrees, and when I do, I end up getting 21.404 degrees. So the answer to the first part of this question would be north, 21.404 degrees, and then which way did I turn? I turned west. Okay, so that's part A. Which way should the plane head? They should head north, 21.404 degrees west, so that then the wind can carry me the rest of the way. The second question is, how long will it take? So we know that the length of the resultant is 600 kilometers, but we don't know the speed on that side. But if we found it and we had its length, then we could find how long. And so now I want to find a side, and this time you have this angle, you have this angle, that means you know that angle. You could use sine law or cosine law. But let's use cosine law just because you haven't yet. So c squared equals a squared plus b squared minus 2ab cos c. So c squared is equal to a, doesn't matter which one you call it, 80 kilometers per hour squared, 240 kilometers per hour squared, minus 2 times 80 times 240 times the cosine of the angle between them, which is this angle. Okay, and when you do the math, you find out that's 111.404 because they have to add up to 180. And so you get a C to be 279.309 if you can punch this in your calculator correctly. So that's the speed. So we know VAV is equal to delta D over delta T. So delta T is equal to delta D over VAV. So it was 600 kilometers over 279.309 kilometers per hour. And so your time ends up being 21.48 hours. Okay? So when you're doing that part, the velocity and the distance have to be for the same side. That's why we needed to find our R. Now we did these in grade 11, but they were always right angle triangles. I promise you they never will be in grade 12. They will always be non-right angle triangles. So we're going to talk about one other thing in the next video, but your homework will be with these guys, okay?